Hey, Algebra 2. We are still in Chapter 1, Lesson 5. Yeah, trying to keep score. Lesson 5. So let's just get going. This is going to be a little bit of a review. We start learning roots in pre-algebra. We may hit them a little bit in algebra. They become really important in Algebra 2. And by the time you leave Algebra 2, you just need to know how everything works without thinking about it too much. So let's just read this. A number r is a square root of a number s if r squared equals s. Okay. A positive number s has two square roots written as square root s and square root negative s. If I just, let's see, it's right over here. If I see, oh, I'm in yellow, sorry, r squared equals s, just solve for that, I'm going to take the square root of both sides. And then when I take the square root of r, that's great. The square root of r squared is positive r or negative r equals the square root of s. That's because if I square this, if I raise it to the second power, positive r raised to the second power is r squared. Negative r raised to the second power is also r squared. So we need to account for both the positive and the negative side of that. Now, this answer right here says positive and negative root x. That just means that, let's see, I can ignore that positive because it's good. Now this one I can multiply both sides by a -1 and switch that negative to the other side. Same thing, okay? All right, so if we look at the example with numbers, because 3 raised to the second power equals 9, and -3 raised to the second power is 9, the two square roots of 9 are square root 9, which is 3, and negative square root 9, which is -3. So the positive square root of a number is also called the principal square root. That's something I've never remembered. It's just not as important in my day-to-day math work. All right, so the expression square root x is called a radical. The symbol here is a radical sign, and the number beneath the radical sign is called the radicand. So we have the radical sign, the radicand is underneath it, and the whole thing together is radical. So we're learning radicals, okay? Here is some properties. So when I have two numbers multiplied underneath a radical, I can separate them. When I have two numbers divided underneath a radical, I can separate them. My example would be root 18 is the same as root 9 times root 2, which is the same as 3 square root 2. If we have this up and down, I can separate that into root 2 over root 25. Root 25, the square root of 25 is 5, so that's root 2 over 5. And notice we're using the principal square roots here, and it's fine. Simplifying square roots, you can use the properties above to simplify expressions containing square roots. A square root expression is simplified if no radicand has a perfect square factor other than 1, and there's no radical in the denominator. Radicals in the denominator are not acceptable in math land. And to put something in simplest form, that means if you take the number and you factor it, none of those factors are perfect squares. Let's practice. All right, simplify the expression. So let me get rid of that yellow. So what I usually do is I take my radical. When I'm first teaching it, I split it up into its factors. It's even, so 2 times 40. It's even, so 2 times 20. It's even, so 2 times 10. Still even, 2 times 5. Now, every pair of 2's I can take out of the radical. Another pair of 2's, I can take 1 out of the radical because it's a square root. And then the 5 is left over. So my answer is 4 root 5. But I can also do this a different way. I can look for perfect squares that go into 80. I know that 80 is the same as 16 times 5. 16 is a perfect square, so I can take the square root of it, which is 4 root 5. Okay, this is probably the more advanced way to do things, and we do this up here when we're still practicing. All right. Push pause if you need to write that down because I'm going to erase it or I will run out of room. Oh, do I have more paper? Nope. All right, so I need to erase it. Did not plan ahead. I'm probably going to do things, I'll do one more sort of the simple way because this takes way too long. I need a big eraser, like a super eraser. So we're looking for perfect squares. Okay, so here I can say that this is the same as 16 times 5, which is the same as 4 root 5. Square root of 6 and the square root of 21. There's no perfect squares in 6 and 21, so let's go ahead and multiply it first. I don't know what 6 times 21 is, and I don't have my calculator handy. So 126. Now, perfect squares of 126. If I divide that by 2, I get 63, which isn't a perfect square. Let me look. I don't see anything that works well for that one. And I don't see the answer in here. That's a bummer. Oh yeah, I do. 9 and 14. I just need a little help. I can divide that by 9. 9 times 14, which is 3 root 14. Okay, here's where I separate the top and bottom. Oops. I figured out how to undo. Control Z. Old school. So square root of 4 is 2, square root of 81 is 9, and we're done. Okay, here I can separate top and bottom. Square root of 7 doesn't do anything, it's prime, and square root of 16 is 4, and we're done. All right, simplify the expression. I can split 27 into a perfect square times a prime number, actually. So that's 3 root 3. 98, not sure. I can do, let's see, 2 times, that would be 49. Oh, 2 times 49. So 2 times 49. 49 is a perfect square, so 7 root 2. Oh, they give us more room on these. 10 and 15 I can't simplify separately, so I can do 150. Let's see, guided practice number 3. That breaks into 25 times 5. 25 is a perfect square. 8 and 28. No idea. I should go get my calculator, shouldn't I? 16, 17, 18, 19, 20, 21, 22. Whew. Ooh, 2 times 112. Sorry, 224, which is the same as 2 times 112, which is 11 root 2. Let's check that. I believe I made a mistake. Nope, that doesn't work. I should go get my calculator. 224 is correct. Eight times 28 is 224. If I divide that by 2, I get 112. And I thought 112 is not a perfect square. I got my 11 perfect square, my 11 squared messed up. So 14 times 14. Nope. 16, let's do 224 divided by perfect squares. Ooh, there we go. 224 splits up into 16 times 14. I just took 224 and I divided by perfect squares because I don't have the high ones memorized. Okay. All right, this next few, I'm just going to write down your answers and you can double check them yourself. It's going to be 3 over 8. going to be root 15 over 2. Notice that all of our answers do not have a radical in the denominator because that's a no-no. That's not simplified. We're going to learn what to do if they don't simplify. If they aren't simplifiable, we're going to learn what to do today, right now. So rationalizing the denominator. Suppose the denominator of a fraction has the form square root b, or a plus square root b, or a minus square root b, where a and b are rational numbers. The table shows how to eliminate the radical from the denominator, and this is called rationalizing the denominator. It's really important in higher level math. We can't have radicals in the denominator, so we have to figure out how to get rid of them. So the expressions a plus root b and a minus root b are called conjugates. We call them complex conjugate pairs or conjugates. Their product is always a rational number. So if the denominator has these things in them, we're going to multiply the numerator and the denominator by these things. What that means is if I have a fraction that looks like this, I'm going to multiply it by square root b over square root b, because this fraction right here is equivalent to 1. So I can do that in math. I can multiply anything by 1 because it's an identity property. And that's how we get rid of roots. So if I multiply across the top, I have root b. If I multiply across the bottom, I have root b squared, or just plain old b. And there is my rationalized denominator. It's the same with, let's just do one of these, a plus root b. I'm going to multiply this by a minus root b over a minus root b. Now in the top, it's easy. A minus root b is left over. I multiply across the top for fractions. And in the bottom, I have to FOIL, which you'll get quicker and quicker at foiling. A squared. Outer is negative a root b. Inner is positive a root b. And last is, I'm so sorry, root b squared. I apologize for that. Poor planning on my paper. The numerator is left with a minus root b. These cancel because it's positive and negative. And I'm left with a squared plus b, because square root of root b squared, square root of b squared is just b. And there's my rationalized denominator. Let's practice with some real numbers. All right, so we have root 5 over root 2. I need to get rid of the root 2. Best way to get rid of the root 2 is to multiply it by, root 2. And I multiply it by the fraction 1, which is an equivalent fraction 1, go across the top, and then root 10, go across the bottom, I have root 4, which is 10 over 2. Here, I need a complex conjugate pair. That's what I've always called it, so they just called it a conjugate pair. I apologize. It's hard for me to change what I say. So the complex conjugate pair is, see, I did it again. It's the exact same rational and radical with the opposite sign. Okay, so I'm going to multiply by 7 minus root 2 because it's 7 plus root 2. Okay, the numerator, just multiply across. I have 3 times 7 minus root 2 over denominator. I'm going to go ahead and FOIL. 49. Outer, that's first, outer, minus 7 root 2, inner, plus 7 root 2, and last is minus root 4. Let's go ahead and distribute this. 3 times 7 is 21, minus 3 root 2, over 49. These cancel, minus 2, because root 4 is 2. 21 minus 3 root 2 over 49 minus 2 is 47. Got it? Okay. Oh, we had more space. And we're moving on. So solving quadratic equations. You can use square roots to solve some types of quadratic equations. For example, if s is greater than 0, then the equation x squared equals s has two real number solutions. These solutions are often written in condensed form, read as plus or minus the square root of s. Okay, I actually couldn't find any explicit problems like this in Delta Math for you to practice, but it's okay. We will be fine. So to solve this, we go back to our algebra skills. I'm going to isolate the variable by subtracting 5 from both sides, and this would be 36. 3x squared equals 36. I'm still trying to isolate the variable, and I have x squared equals 12. Now, to solve, I take the square root of both sides, because in algebra, whatever I do to one side of the equal sign, I have to do to the other. So I have x equals plus or minus root 12. Now that's not the simplest form. So x equals, let's rewrite that, plus or minus 12 is the same as 4 times 3. And 4 is a perfect square. 2 root 3. This means I have two answers. X equals 2 root 3 or negative 2 root 3. Or we just say plus or minus 2 root 3. Not so bad. And more paper. All right. So now we have a binomial. Okay, we do it the same way. We're going to break it down, isolate it, get our algebra skills out of our back pocket because we can do that. Right? So to solve this for z, I need to go from the outside of the equation in. First, I have to get rid of the 1/5. You can either divide both sides by 1/5, or what I usually do is multiply by the reciprocal. And if I multiply by one side, I have to multiply by the other. Okay, these are canceled. I'm left with z plus 3 squared equals 35. Now I have a squared here, and the z is inside of it. So I can actually take the square root of that side and the square root of that side. And I'm left with z plus 3 equals plus or minus root 35. Almost done. Add 3 to both sides. Nope. Subtract 3 from both sides. Z equals negative 3 plus or minus root 35. And I can leave my answer like that, or I can see that they wrote them both. Negative 3 minus root 35 and negative 3 plus root 35. Doesn't matter. All right, let's practice a little bit. I messed this thing up and I could not fix it. So right there is what it's supposed to look like. So let's just separate it and multiply by square root 5. I just take the denominator and multiply it by square root 5 over square root 5, which is equivalent to 1. And I get root 30 over 5. Square root 9 over square root 8. I can actually simplify this first if you think about it. 8 is the same as 4 times 2. So I can actually just multiply this by root 2 over root 2. There's a gnat in my room. That gives me 3 root 2 over 2 root 4. Trying to get my coffee. Which is the same as 3 root 2 over 2 times 2 is 4. Now what would happen if we had multiplied it by root 8? Let's try. So let's redo it. It means I have 3 over root 8 multiplied by root 8 over root 8. That gives me 3 root 8 over just plain old 8. I can actually simplify that numerator. 2 root 2. And I can simplify this. And I end up with the same answer. So if you think about it, simplify first and then keep going in your math. If you don't, you'll still get to the most simple answer. All right, I'm going to give you the answers to these. You can practice them on your own as soon as I find them. Because there's a lot of guided practice. And if you can't come to the same answer, just shoot me a note. I'll help you. See, there's so many of them. Okay, I'm going to do this one with you. I'm going to multiply by the complex conjugate pair. See how I just take the denominator and I change the sign? I can distribute the numerator. -6 times 7 is -42, minus 6 root 5. And then denominator, I'm going to FOIL. First is 49. Outer is positive 7 root 5. And you can skip this step as you get more used to it because those middle terms are always going to cancel. Okay, it's kind of magic. So that gives me -42 minus 6 root 5 over, those cancel. That becomes a 5. 49 minus 5 is 44. I can simplify this a little bit. We're talking higher level math now because those are both even and those are both even. So I can divide everything by 2. That gives me -21 minus 6 root 5 over 22. 13. Yep, just wanted to check my answer. Okay, that was a tricky one. All right, 14, we're going to say 8 plus, nope, 8 minus 2 root 11 over 5. 2 more. Actually, no, way more. Complex conjugate pair, 15. -9 plus root 7 over 74. 32 plus 4 root 3 over 61. Now solving equations is where we started. I told you I couldn't find any explicit problems like this. X squared equals, let's see, 116. 5 goes into 8, 1. There's 3 left over. Yeah. Then I take the square root of both sides. X equals, don't forget your plus and minus. Add 7 to both sides, which is 36. Z squared equals 36. Squared both sides. Don't forget your plus and minus. Okay, this one, the one that's a little bit tricky, means I have to, if I'm trying to solve for x, I have to work from the outside in. So I'm going to divide both sides by 3 first. And I have x minus 2 quantity squared equals 1. 3 goes into 4 once. And I have a fraction left over. That's odd. They usually give us very divisible things. Yeah, that's awful. So we're leaving it 40 over 3. Square root both sides. X minus 2 equals square root 40 over square root 3. I have to simplify it. 4 times 10. 2 root 10 over root 3. I'm already out of space. I didn't know this one was going to go so long. So now I have to rationalize it. Let's see, that gives me 2 root 30 over 3, plus or minus. Because we're all over here, and this is all plus or minus. But we're not done. That was still x minus 2 equals. So I need to add 2 to both sides. Oh golly, I'm so sorry. Add 2 to both sides. I get x equals 2 plus or minus 2 root 30 over 3. Check the answer and make sure, hey, we got it right. That's so exciting. Lots of steps, okay? All right, let me look. I'm actually going to skip this last one, and it's okay. We've got everything we need for our homework, and we will be successful. So I'm going to go ahead and stop the video and work on the next one. Good job.